Okay, so today what we're going to do is review electron configurations and learn a little bit about D-block electron configurations for D-block atoms, okay? So we're not going to get all the way down here to the 6th row where we'd be worrying about the F block, but we absolutely are going to get through the 5th row. We could do like the 6S block if we wanted to, okay? So that's where we're heading with this. But first, a little bit of review, right? So Leslie, pick an atom within the first 3 rows, any atom. S, this one right here? Okay, sulfur. All right, scholars, so with a partner or with your group, please go ahead and figure out what you think the electron configuration for sulfur should be. Go ahead. And then Leslie, you can write S, colon. And we're going to put all the electron configurations on. Very good. But it's not, sorry, it's not S4, it ends in, that's not the S block. Or it ends. Which block is that? Okay, raise your hand if you can hear me, please. All right, so which block is this? S block. Which block is this? Which block is this? P block. Okay. Are we confident? Can we get this one done? All right, sulfur. Let's get started. Ready, go. 1s2, 2s2, 2p6, 3s2, 3p4. Very good. Okay, 3p4. All right. So if we can get to sulfur, then it shouldn't be too much trouble to describe the electron configuration for magnesium. Can we do that one? Yep. Okay. Take 15 seconds with your group, just kind of review, and then we'll go to magnesium, okay? Go ahead. Yeah, Mg. Capital M, lowercase g.
That one, right?
Okay, we got this? All right. Ready, go. 1s2, 2s2, 2p6, 3s2, 3s2. Good. Okay, so let's go ahead and do this one because it's the most important atom for, well, it's hard to say that, right? Because you need a bunch of atoms, but it's an extraordinarily important atom for life, okay? Carbon. Carbon is number 6, okay? It's right here in the 2nd row. Which block?
Second.
Which block? P block. Okay, so give yourself about 10 seconds and then we'll go through the electron configuration for carbon. Ready for carbon? All right. On the count of 3. 1, 2, 3.
1s2, 2s2, 2p2.
Good. 1s2, 2s2, 2p2. Very, very good. Okay, so now let's have some fun. Let's get a little further along in the table. So we're going to go all the way over here to titanium. Titanium's number 22. And I want you to go ahead and use your rules and tell me what the electron configuration for titanium should be. Titanium, okay? And titanium is in which block? D block. D block. F block's down here. D block's up here. Okay, titanium's in the D block. What should be the electron configuration for titanium? Alright, let's give it about 15 more seconds. Okay, let's give this a shot. Titanium's down here. Here we go. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4d2. Okay. You guys used all the rules that I gave you. You used them exactly as I described, and you were wrong. Wrong. Because I didn't give you a second rule that you're going to, or an additional rule that you're going to need. Okay, I gave you 3 very good rules, right? You start with the row, then you go with the block, and then you go with the number of elements in the block. Okay, in that row. Here's the thing about the D block, okay, and this is why we waited until now, because it becomes a lot, it would get confusing if you tried to incorporate this rule with the other ones initially. The D block elements, for electron configuration purposes, are a row behind the S block elements and the P block elements. So, this one goes 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, what's 4 minus 1? 3d2, okay? 3d2. This one ends in 3d2. Go ahead and write that down, okay? And write down that little rule. The D block elements are one row behind the S and the P block elements for electron configuration purposes. And we'll get to a point at which we'll understand why that's the case. But right now we have to learn this process of getting electron configurations. Very important. So 3d2. Okay. Whew. Let's go back to titanium. Again, let's repeat it from the top. Okay? Count of 3. 1, 2, 3. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. Very good. Okay, so let's have a little bit more fun, and let's head all the way over here to palladium. Okay, PD, palladium. So palladium is in the 5th row. Okay, but this is 3d. What is this row? 4d, even though this right here is 5s, okay? That's our distinction. Now we know enough, we've done very well, now we can take on that additional rule. So, palladium, number 46, with your group, take about a minute, and then we'll go through it as a class. Go ahead. Okay, so palladium, okay, palladium. We got this? Okay, on the count of 3, 1, 2, 3. 1s2,
2s2, 2p6, 3s2, 3p6, 4s2,
3d10, 4p6, 5s2, 4d8, right? You count 1, 2, 3, 4, 5, 6, 7, 8. Okay, 4d8. And if you put that down on a quiz in my class, you will get 100% credit because you're executing the rules that I need you to know. It turns out experimentally that this D subshell can hold how many electrons, guys? We got how many columns here? 3D how many? 10. You can have up to 10. So here's what's, this is 4D10. Okay, you can have 4D10, 3D10, any D level can be 10. It turns out that palladium actually wants to have a full D subshell more than it wants to have 2 5s electrons. So it's got an exception for electron configuration. You would not get a bad grade if you missed this on a test. I wouldn't expect it. But it turns out that it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, and it's not 5s2, it's 5s0, and then it goes 4d10. So those 2 electrons actually get shuttled into this spot, into the 4D subshell, because having that full 4D subshell provides an energetic stabilization that is better than having 5s2 4d8. So it's a special case, but you did a perfect job. If you wound up with 5s2 4d8, that was exactly what I wanted you to do. If you want to put that little note that it actually has a special case in this situation, that's fine. Otherwise, if you want to leave it as 5s2 4d8, you are good to go until like pre-med chemistry in college or honors chemistry in college. Yes?
Can you repeat the configuration?
I could, but Leslie has conveniently put it on the board for us. The only thing is this would be a 5s2. Okay, if you consider palladium at that 5s2 configuration, 5s2 4d8, I'm okay with that. The actual experimental electron configuration is 1s2 2s2, 2p6 3s2, 3p6 4s2, 3d10 4p6, 5s0 4d10. Okay, so it's really the same as what Leslie's put on the board, except experimentally it's actually 5s0 4d10. And you need not know that. If you write down what she's put here or what you came up with just a few minutes ago, that's fine. I'll give you full credit. Don't worry about the case. The fact that this is a special case electron configuration. Okay. I'm actually going to use a different example, rhodium, for my other classes. Okay. I'd forgotten this guy was a special case. What now?
I'm confused because I got 4s2, 3d10, and 4d8.
Okay, almost. 4s2, 3d10. Well, we got to go all the way here, right? So then you still have to go through this part of the table. 4p6, right? Then you got to come back around, 5s2, then you go 4d and you count 8. And it turns out that those 2 electrons actually want to be over here, so you've got 5s0, 4d10. You forgot the 3d, that should be 3d10. Then we have to have, go ahead and update that a little bit. Yeah. So 3d10. Okay, you have to use 2 lines, huh? 3d10, 4p6, 3d10, 4p6, yep. And then next level, okay? And do 5s2. And then 4d8, okay? And then just so that we know that, so this is where your rules will get you. You can have that or 5s0, 4d10. Either of these I would accept on a test or a quiz, okay? All right, so now that we can do this, we're going to be ready for our quiz on Wednesday. Okay, so we'll have a quiz on this material Wednesday. Getting to a D block element, that's going to be your extra credit. The first 3 rows, those are normal credit. That's expected, okay? All right, any questions for me? Okay, so we'll have a little bit of review right before our quiz on Wednesday. Otherwise, I think you have a lot of good information to study between now and then, okay? Thank you, scholars. Very good job today.